All right, today we're going to start a new chapter, chapter 6, and I think it's about factoring. And section 6.1 is the GCF and factoring by grouping. Okay, question 1, identify the greatest common factor. Okay, if you can't see this without using a calculator or a factor tree, I'm going to show you a couple ways to do it. So let's go over here and do a factor tree for 20. Any two numbers that divide into 20. So let's go 2 and 10. 10 is going to be 2 times 5. So the prime factorization of 20 is 2 times 2 times 5. For 45, I have, 5 times 9, and 9 is 3 times 3. So the prime factorization for 45 is 3 times 3 times 5. Okay, now, what's the greatest factor that I have between both of them? I see both of them have a 5, and that's it. So the greatest common factor is 5. Now to do that on the calculator, you hit math, arrow to the right, number, and then number 9 says find the greatest common divisor. And you want between 25, 40. And you see that the calculator tells you the GCD is going to be 5. Okay, number 2, identify the greatest common factor, 6xy and 7. Okay, for 6xy, for 6 I have 2 times 3. So I have 2 times 3 times x times y. And then I also have 7 times y. So the greatest common factor, both of them have a y, and that's it. So the GCF is y. For number 3, find the GCF. The number 20 is 2 times 10. 10 is 2 times 5. So for 20xy, prime factorization, I get 2 times 2 times 5 times x times y. Now for 15, 15 is 3 times 5. So I get 3 times 5. Now x cubed, x, and a y. Okay, what's the greatest common factor on all of those? I see a 5 in common, and I see an x in common. That's it. So my GCF is 5x. For number 4, find the GCF. The first term is 4 times w minus z. So I have 4 is 2 times 2, right? So I have 2 times w minus z. Now with 5 times w minus z, 5 is prime. So I have 5 times w minus z. Notice that w minus z is a factor. It's a binomial. And in fact, it's a common binomial factor. So the GCF between those two terms is going to be w minus z. Okay, now we get to start using the fact that we can identify GCFs. So question 5 says to factor out the GCF if possible. So I'm going to ask, does 4p and 24 have anything in common? They're both even numbers, so at least a 2 could be pulled out. In fact, a 4 can be pulled out. So if I pull out a 4, what would be left? 4 times what gives me 4p? The answer is just p. Minus 4 times what gives me 24? And it's 6. So 4 times p minus 6, we've pulled out the GCF of 4. Now I can check this by distributing, that's 4p minus 24. That's just a little mental check that I do. The answer, factor out the GCF. The GCF is 4. It's not that one. It is not prime. And in fact, it equals 4 times p minus 6. I pulled out the GCF. Number 6, factor out the GCF. Okay, what is the GCF between 6p squared, 18p, and 30? Okay, p squared, p, nothing. So you can't pull a variable out. Okay, with 6, 18, and 30. 6 is 2 times 3. 18 is 2 times 9, which is going to be 2 times 3 times 3. 30 is 2 times 15. 15 is 3 times 5. So I get 2 times 3 times 5. So what's the GCF with all 3 of those numbers? I get a 2 in all of them. Ooh, and I have a 3 in all of them. So the GCF is 2 times 3, which is 6. I can pull a 6 out of everything. What would be left? 6p squared minus 6 times what gives you 18p? 3p plus 6 times what gives you 30? 5. So the expression is not prime. In fact, you can pull out a 6 and you're left with p squared minus 3p plus 5. Number 7, factor out the GCF if possible. The first term is t cubed. The second term is t squared. What can I pull out from both of them? Both of them have a t in common. Both of them have another t in common. So the GCF is t squared. It's t times t. So I'm going to pull out a t squared. What's remaining? Okay, t squared times what gives you t cubed? Now look over here and I still have a t left. Plus, t squared times what gives me t squared? It's just a 1. So if I factor out a t squared, my remaining factor is t plus 1. If you were to go check it and do your distribute, you would get t cubed plus t squared, which is what you started with. Number 8, factor out the GCF if possible. Okay, for 9ab, prime factorization would be 3 times 3 times a times b. For 12a cubed b, 12 is 4 times 3. 4 is 2 times 2, so 12a cubed b is 2 times 2 times 3, a times a times a times b. All right, what's in common? I see a 3 on both of them. I see an a on both. And I see a b on both. So the GCF is going to be 3ab. That's what I'm going to pull out, 3ab. Now, what remains? Over here, I can see that all that remains is a 3. So just to check, 3ab times 3 gives me 9ab. Okay, minus. What was remaining over here? I had 2 times 2, which is 4. A times a is a squared. Now, if I check that, 3ab times 4a squared, 3 times 4 is 12, a times a squared is a cubed, b. That's what I should have. The answer will be, it is not prime. You factor out the GCF of 3AB, 3 minus 4A squared is the remaining factor. Number 9, factor out the GCF. Okay, for 80, I see 8 times 10. 8 is 2 times 2 times 2, and 10 is 2 times 5. So for this first term, I have 2, 2, 2, 2, 5, and then there's 1, 2, 3, 4, 5 x's and 3 y's. Okay, for the second term, 15 is 3 times 5. So I have 3 times 5, x squared, y. All right, what all is in common? I see a 5. I see an x, and a y. So my GCF is 5x squared y. That's what I'm going to pull out. All right, what's remaining? 5 times what is 80? Well, 2 times 2 times 2 times 2. So that's 16. I still have x cubed, and I still have y squared. Plus, all I have left over here after I pull out the GCF is a 3. So I get 5x squared. My answer is going to be 5x squared y times the factor 16x cubed y squared plus 3. Number 10. You should be moving towards being able to look and see what you can pull out. I know that the greatest common divisor between 6 and 9 is 3. If I have x to the 4th and x, I can only pull out 1x. If I have a y to the 4th and y to the 7th, I can pull out a y to the 4th. There's no z here. There's a z there. I can't pull that out. So you should be moving towards that direction, being able to just visually tell. However, if you can't, I'm going to do the prime factorization of 6, which is 2 times 3. So this first term, I have 2 times 3, and then 4 x's and 4 y's. For the second term, 9 is 3 times 3. So I have 3 times 3 x, 7 y's, and a z. Okay, what all is in common? A 3, an x, 1, 2, 3, 4 y's. So my GCF is 3x y to the 4th. And that's what I pulled out here. All right, what remains when I factor the GCF out? In this first factor, I have 2x cubed minus the second factor, I have 3y cubed z. So my answer, when I factor out the GCF, 3xy to the 4th, the remaining factor is 2x cubed minus 3y cubed z. Number 11, for that polynomial, first it wants you to factor out negative 3t. I'm going to rewrite it. Negative 3t cubed minus 6t squared plus 9t. They want me to factor out negative 3t. What remains? Negative 3t times what gives me negative 3t cubed? T squared. Okay, I want to factor out a negative, so this turns into a positive. 3t times what gives me 6t squared? 2t. 3 times 2 is 6. T times t is t squared. Okay, if I factor out a negative, this turns into a negative. 3t times 3 gives me 9t. Okay, if I factor out a let's check this just in case. What is that? Negative 3t, t to the 1, t squared is cubed. Negative times a positive is a negative, and I would get 6t squared. Negative times a negative is a positive. 3t times 3 is 9t. That's what I started with, so I did that correctly. So the answer for part A is here. We're going to do this again. Let's write the polynomial again. Negative 3t cubed minus 6t squared plus 9t. But this time we're going to factor out just 3t, not negative 3t. So 3t times negative t squared minus 3t times 2t gives me the 6t squared, plus 3t times 3 gives me 9t. So the answer for B is here. That's where I'm going to stop this video.